lovely people. How are you? How's day 2? How was the day 1? I mean, especially the evening. Okay, so there was some kind of evening. I like it. Take your seats. Yes, so we are starting the 2 of Devox, Devox Belgium. Like I could say, long time no see, right? So I guess, I don't know about you, but I was missing these conferences quite a lot. The chance to meet together and have these lovely chats and presentations and everything. So welcome to my talk/deep dive, Java 18 and 19, what's new and noteworthy. Quickly about myself, this is me. So my first name is Piotr and my last name is, yes. I hope the other things won't be as complicated. So apparently in Polish, Y or Y is a vowel. So contrary to my German nickname, I'm not Piotr ohne Vokale or vowelless Piotr. It reads Przybyl. Yes. If you need to send me like some questions or some hate or whatever, this is like my Twitter handle, so you can go for this. I am working as a software gardener, and if you don't know who knows what software gardener means, what this role means, like this position. I mean, the lights are blinding me, but I don't see a single hand raised. Okay, so it means you need to read a fantastic book called The Pragmatic Programmer. I didn't invent this, so there is like the description, what it means to be a software gardener. Basically, it's about taking care of the software as it grows, taking out weeds, right, getting rid of bugs and everything. Sometimes I also work as a trainer, and sometimes, of course, just like today, I'm giving public talks, right. Day by day, I work for a very nice startup called Atomic Jar, right? And what we do, we work on test containers, like we support test containers, the free and open source libraries and things around. So I'm the most of the time I'm a software engineer for the around things. I'm working on test containers cloud, right? And from time to time I post something on my personal web page, like my talks or something called softwaregarden.dev. Yes, who is programming in Java? Most of us. Okay, who's not doing Java? Okay, just a few people. Righty. So let's now do this. This mandatory. What version are you running? Stuff, right? So who's using Java 17 or above? Okay, 11. Okay, still 8. Ooh, okay. I get it. Now I have the picture. Yes, so I've been doing Java or JVM stuff for most of my professional life. Java has always been somewhere there in the background. Even when I go on a holiday, Java is still there. Provided there's a holiday, there are no lockdowns and everything like this, right? Okay, so we went through who are you. So yes, most of us are the Java developers, it seems. Yes, a little bit like a warning or safe harbor statement, caveat auditoris, right? Who knows the caveat emptor rule? Let the buyer beware. So this comes from like Latin, from Roman law. So it's like, I mean, I've never bought a house in the US, but apparently it works that way. So it's not the seller's responsibility, but the buyer's responsibility, right? So caveat auditoris means let the audience beware. So it's on you to verify, right? If what I'm saying is correct. So you shouldn't trust talking heads, especially if they're talking to you on the internet, right? You should try to reason on your own and stay sane and everything, right? So it's also your responsibility. Making mistake is a human thing. And yes, also let's be aware of this, that I come from Poland, right? I live in Poland. I don't work in Poland. I mean, I work remotely. At Atomic Jar, we are a remote first company, right? So everyone works remotely. There is no such thing as an office where we can like assemble, basically. But I love this thing very, very much. I don't know if you've seen this. This is like the objective distribution, like how people thing. So there is this objective one, so things are they junk or pretty good, and they are awesome. For Americans, like most of the things is awesome, right? Do you have any fellow Americans here? Okay, no one across the pond. But in Eastern Europe, it's like, what is this garbage? I don't like it, and there's the even so, right? So I'm not quite sure, like, I'm somewhere in between, right? And of course, for the British people, it's always fine. Right, so keep that in mind. So this is how it works, right? So we're gonna see a few I don't like it things and a few even so things. Things might not work today, or they might work. I don't know. It hasn't been decided yet. It's up to us how it works. And we're gonna ask ourselves some questions, and we're gonna to seek for the answers in the code, right? Questions sometimes are tricky. For example, let me ask you this question: is a crocodile more green or more flat? Yeah, who says crocodile is more green? And who says it's more flat? Yes, of course, you want jellies, sir. I have some jellies for you from Poland. Can I throw it? Will you catch it? Let's try, okay? Jelly handling. Yes, very nice. Yes, so of course, crocodile is more flat than green because it's flat from top and the bottom, and it's green only from top. Easy. Right, so Java 18. Right, and the plan for this deep dive today is like, boy, we haven't met since Java 13. I mean, the very last Devox before this event taking place this week was about Java 12 and 13, right? So today it's Java 19. I mean, these folks from OpenJDK and Oracle, I mean, they issue like crazy, right? New stuff, and we have to migrate, and we have to learn about this. I mean, it's so awesome. Yes, so today I'm mostly going to focus on Java 18 and 19, but shall we have some time? And you shall have some questions, because there were many hands raised for Java 11 and 8. If we manage to have some time, we'll try to get back and, for example, cover some nice and neat stuff from Java 17, for example, right? What's really cool about this or that version, right? So Java 18, it was released in March this year. It had 9 JEPs in total. These are, by the way, working links. The whole presentation is online, the code is online, so everything should be there for you, right? You should be able to clone it and experiment on your own. There are some preview features like pattern matching for switch. There are some incubator modules, or were in Java 18, because theoretically it's no longer supported. And for example, finalization for removal got deprecated. Finalization got deprecated for removal. Yes, English is not my mother tongue. And there are also other features, and these are the JEPs. This is the exhaustive list of the JEPs included in Java 18. And in Java 19, so it came like, as we should have expected, it came 6 months later, so it's not even a month old, right? So it had 7 JEPs in total, and again, link for release notes, so we can read the whole like changelog, be aware of this, and do that and everything. And it has some preview features. So for example, foreign functions and memory API got kind of, I don't know, switched to or promoted from incubator module to preview feature, but we still have incubator modules like vector API and or structured concurrency, and there of course are the issues. And here is the exact list of these 7 JEPs. We're not going to go through all of them. For example, I'm not going to touch this RISC V port. Basically, if you have this CPU, now you can run Java on this CPU, right? There's a new official build for this, and I'm not going to touch Vector API because we might run out of time. And Vector API is very nice if you have basically like a lot of data, like lots, like tons of data, and instead of doing or processing them in sequences, right? In a sequential way. Like take the first one from this array, take the first one from this array, add them and store in third array. You can use that instructions from our CPUs or from your CPUs that they're able, for example, to do like this in a kind of like in a batch way, right? So they can take 4 elements from this array, 4 elements from this array, and add them and put 4 elements in the result, right? So this is like more or less the vector API, and it's about making this transparent. So when your CPU supports this, it should work. When it doesn't, then it should gracefully fall back to this sequential mode of operation, if you will. Yes. So these 7 JEPs, I guess that would be all. Thank you very much. Go and enjoy other rooms. Right? Yeah. Thank you. That's very kind. We still have some time left, so maybe let's go to some details. Yes. Question. You're in this room because you're intrigued. This new Java thingy, but it's not LTS. What shall I do? Shall I go for it? Shall I not go for it? Like questions, right? Unfortunately, this time 42 might not be the answer. So it depends, of course, right? I would say if your software runs on Java 19, why not trying Java 19? It's as simple as that. I would say this should be our default mindset. If your thing runs on the most recent version of Java, just bump it every half a year, right? Just tune this from in your Docker Compose or whatever you're using, and that's it. That should be it, right? Maybe you should skip using in production these preview features or incubator modules, right? Or maybe you shouldn't. Like, for example, we are using preview features in our production code, right? And they are running very nice, and they are like awesome and dope, right? But we use that for microservices. So we follow this very nice definition of microservice, that it's something that you're not afraid to like scratch and rewrite in like 2 weeks, right? If you can't do that, it's too big. It's not microservice. It's basically a service, right? So therefore, if there's something that we should like rewrite or touch, we can do that. There's no big pain for us, and we already benefit from certain preview features, right? And one thing I can't stop stressing enough is that LTS isn't like banana soft or monkey soft, because it's not LTS, so it's like some kind of like or meh at the best, right? It's not true. The true meaning of LTS. I hate the walls of text. You're gonna see now a wall of text, right? And just don't go through the wall of text. I will point you to the important thing. So it is a quote from Mr. Mark Reinhold, right? You might know the name, one of the core Java people, right? And he was quoted by David Delabasset because some people were kind of like, before Java 17 got released, were kind of like in this mindset of trying to push the Java team, like, instead of working on new features, you guys should stabilize this, right? Because it's LTS, so it should be like extra stable, extra safe. We're not after new features, we after stability, right? And maintainability. English, right? And this is what Mr. Reinhold replied, right? And he wrote that please proceed with the usual high level of care and consideration. So it's the high level of care and consideration is the default one for every Java version, right? And whether the target release is an LTS or not is almost always completely irrelevant, right? Technically, there is no difference between LTS and non-LTS version. It's for these people who don't know, I don't know, like they need like some kind of certification, or doing a thing twice a year is like too often for them, or something like this, right? LTS is most of the time like the business term. It's not something that is technical, right? All right. There might be, I'm still like not certain, so this is one of the things that might not work or might not work. There might be a change in the LTS cadence, so LTSs might be released not every 6 releases / 3 years, but every 4 releases, like every 2 years, right? We'll see with version 21 whether it's going to be LTS or not. Okay, and now let's go to the JEPs, right? So we're gonna fly through the JEPs and see what nice things they have inside. So UTF-8 by default, which is a standard feature in Java 18. This is the JEP. You can click on it. It will like usually it works like this. You click on these links, and this opens you the whole description of the JEP, right? I encourage you, like, if you need to familiarize with yourself, like what this actually means. And they are divided in very nice sections, which I really like. So there are goals, there are non-goals, like let me make this bigger, right? Goals, non-goals, right? What was the reason for making something or to happen, right? And there's a description, like what you should do, how you migrate, and everything. And sometimes at the end there is, for example, this risks and assumptions. Right, and also the alternatives. So as you can see, there is like a very nice document. It's not like RFC exactly, but it's like moving into that direction, and I like them very much, right? You should always basically listen to that Spanish guy called Manuel, right? Yes. So what this change is all about is that the things from Java IO will now use UTF by default. Printers, writers, readers, you name it. Of course, unless you specify another character set. Yes, it's pretty big, right? So there is now for file encoding, we can set either UTF, right, or compat. Compat would mean, if I'm not mistaken, that it should like be like it used to be before. And yes, now if you go for the default, it will throw an exception, right? So please, like, you may need to evaluate your code base for this. If you don't have source code in UTF-8 due to whatever reason, I don't know, then of course you can also specify it using this encoding parameter /flag. And if you're not able to migrate to UTF, like turn your files, for example, then you should use explicit character. This sounds scary. I would say like this. This shouldn't be a problem for Linux users unless you have some weird encoding set. This also shouldn't be a problem for Mac users for last few versions or even more. This might be a problem for Windows folks if they keep, for example, text files not in UTF-8, right? And how it looks like something like this, yes, we have this encoding check, righty, and let me run this. The code should be in a runnable state. Yes. Let me read this for you in Polish. So it says, pchnąć w tę łódź jeża lub 8 skrzyń fig. And it doesn't make much sense. It's basically using every character from Polish alphabet. That's the purpose of this sentence, right? And if you keep it as UTF-8, I have two files here. This test UTF and test Windows 1250. Then when I'm using my default UC encoding, then it's gonna produce this output, and it looks weird for Windows 12.15 encoding, right? Which might be, or could have been like the default for like Polish or like Central Europe thing. And if we go here, like, what does it mean? If you go for car set for name, and now let's go for Windows 12.50. Am I doing this correctly? Or required type? Oh, sorry, in the wrong place, I assume. How about here? Yes, let's run now. So now I'm emulating how things are running on Windows, right? I'm not gonna run this on Windows. Yes, so as you can see, on Windows, this looks correct, this thing. It has 51 characters and everything, and the UTF-1 looks like a rubbish, right? So ideally, you should always use streams, printers, and writers with explicit character set, right? If you're not, it might be time to migrate your stuff and everything. Basically, be aware of this, especially if you're like, who's running stuff in production on like Windows? oh yes. So if you're using these fancy languages, you might need to take a look at this chap and like be aware of this, because I expect after migrating to, for example, the next LTS, many funny things will happen in the user interface, like bank statements or whatever, right? Yes. So keep that in mind, please. Let's go next. Deprecate finalization for removal, standard feature of Java 18. This is the JEP. So who's using finalize method? Very nice audience, just a few people. Yeeks. Very nice. Okay, so finalize is in general bad. You shouldn't be doing this, right? And now folks maintaining Java are doing like some real efforts to make sure that we are not handling it wrong, basically. So now when you're going to use finalize, we're going to see compiler warning and Java flight recorder event. And we can simulate what will happen in a future version by just disabling it, right? So we can use finalization disabled, and in some future versions, they might need these versions like finalization enabled. And perhaps, I mean, it's not carved in the stone, right? Maybe we will see object.finalize bye-bye going whoopsies, right? That would be even nice, right? But we'll see how the industry/community will react to this. So let's go for this finalization, finalizers, yes, here, yes. So it's demo only. It's demo, right? You don't stuff like this in your production code. So what do we do here? Let me see what's the... okay, we're not doing much. So it's important to set like a quite low memory. And what we're going to do is, as you can see, we have this atomic log, and we're going to basically create objects, right? And we have this finalize method. And as you can see, IntelliJ says it's deprecated and marked for removal, right? And many things might happen with finalize. So we may forget to, for example, call super, right? And then we might be still like using thread and stuff like this. So it seems, you see, it's like this code doesn't look that dangerous. Okay, so in finalize, we are not freeing any resources. We're just printing to standard output, right? How hard can it be? Right? It looks so nice, so innocent, so even cute, just telling us, yeah, like we are finalizing. Oopsies, like out of memory error. Any reasons why this could have happened? And even so quickly. Well, apparently, writing this to standard output may take more time than creating new objects, right? So that's it. You see, these objects aren't like, I don't even add them anywhere. So they can be garbage collected. So the only thing that's preventing or slowing down the garbage collection is this print line. That's the thing. So now let's go with finalization disabled. Let's emulate what future versions of Java might do. Right. So finalization disabled, and let's rerun it. As you can see now, it's running pretty smooth, right? It's still, oh my gosh, it's still growing. See, it doesn't stop. So, I mean, it doesn't crash. No, it will stop now because I told it to stop. So yes, please be aware that using finalize has been marked as bad code, right? It's really time to stop using it. And I like this job very much. I mean, everything that's cleaning, like doing this stuff for sanitizing the serialization, like the previous stuff, or like preventing us from this reflection and stuff like this in previous Java versions. I like it a lot, basically. Okay, simple Java server. Another feature for 08. I don't know what the response code that is. I can't remember. So there is a thing called, surprise, surprise, simple web server. It exists for only for testing and development purposes, right? You shouldn't be running production using this simple web server. And because, for example, it has no HTTPS and other sophisticated features. It's HTTP only. It can be called from CLI, or it can be started programmatically in Java, right? Yes, so let's see how this thing works. And for that, we should go to, okay, so in the resources, I have, as you can see, for the server, can you see it okay, or shall I go for the presentation mode? It's okay, right? Because I would say presentation mode confuses not only me, but also people, because this is not how you usually work with your IDE, right? So yes, so we have this few HTML files, as you can see. We have like a simple CSS file, and now I'm going to do the RTFM, right? So this is what we shall do in this very example. So let's go to the terminal, maybe here, because I need Java 18 or 19 for this. Yes, it's 18. Very nice. Very, very nice. And now let's do the thing. Yes, okay. So by default, it's binding to port 8000. So now let's go and see what's in there. And this is like this whole page, right? Because this is this index HTML. So this is it. See, it's so simple. It's so dumb. And now I can click on A, B, and C, and it doesn't do much, right? It's just this, right? And maybe you'd like to create this simple web server for some testing from your code. So where is it? Here, server, simple server, right? Again, demo only. This is non-prod code, right? So what we're gonna do this time, let me stop this thing, although like I'm gonna use different ports. So this time I'm going to bind to port 9000, and I'm going to host everything from this server, right? From resources, and log stuff, which is info only. And then like one thing in this style CSS, I'm gonna dynamically replace. I mean, I would say it's perhaps already the abuse, like you shouldn't read the whole file or like at once to memory, especially at the whole every request and everything. Yet we're gonna replace Indian red with dark blue, right? And this is what we're gonna do, right? 200 and the response and everything. Yes, so we're gonna handle this style CSS request in a special way. Let's go there. Come on, come on, come on. Is it running? It should be running. Now let's go to, okay, let's go to localhost 9000. See, so now it has different color, right? It has this dark blue color, so it's now, we started this programmatically, did a little thing, and that's it. Where can it be useful? We're gonna see for the next change. Right, let's stop this. Yeah, very nice. Okay. So code snippets for Java API in the documentation. Another standard feature. So 4.13, we have this new tag, snippet, which we can use in Javadocs. Who's writing Javadocs? Who's reading Javadocs? You know what's funny? I would say there's slightly less people who's reading than who's writing. What does it say about our industry? Okay, maybe I miscalculated the hands. Okay, never mind. So it's gonna apply this modern styling, right? We all remember when Javadoc changed its styling not so long ago. And it's going to be easier to validate and support these code snippets in IDE, because it's not going to be this code or pre or whatever. This is going to be like proper Java code. And it's not interactive. It's nothing like Swagger-like or like this JFiddle or other things like this. Or it's not JShell-ish by any way. It's just, it generates static output, meaning you can SCP that, for example, to a server or run it like from static files on your machine. And it supports so-called internal and external things, and not only Java syntax. How does it work? So we have this Javadoc sample. And this is how it looks, this Javadoc, right? So as you can see, I have just a class. It's like what this class does, it doesn't do anything beside being like a stub for or excuse for using the snippets, right? So don't focus about the Java code. So as you can see, I'm writing that this Javadoc sample can be created as this snippet or as this thing. And as you can see, IntelliJ already applies like a slightly different color and background and everything, meaning it can interpret this code, right? And I can also use, and this is the internal snippet, it can also be external. As you can see, I can tell for this snippet, use the file which is sample demo. So I can, for example, have another file which is demoing how I can use this other thing, right? So this is like intended usage, for example. And here I'm including, in a way, the whole file. And here I'm just saying, okay, use only this usage region, right? And the usage region is in here. So it starts here and it ends here. Okay. And this is it. So this is the Javadoc, and I have another region here which is full constructor, as you can see, default constructor. So I can like add this stuff to my code to make it look better. And how are we gonna generate this? RTFM, righty, and yes. Okay. So where's the terminal here? And let's go back. And now now I'm gonna go into this directory. I'm gonna generate Javadoc for this source path, and as you can see, I have this snippet path, right? Which is the path for where I keep these external snippets. Righty. So these files got generated, and now how can we browse these files? For example, we can now use this JWeb server, right? We don't need anything else for demoing purposes. Yes, so let's go here. And let's just refresh it. And you see how it works, right? So it's just this Javadoc sample, voila, voila. And yeah, so this is the snippet, this is the snippet, this is the whole file, external file, and this is just the region from the external file. You can see I have these very nice copy icons here, right? So people can copy, and they like, we are nice now. They don't have to go to Stack Overflow to copy their stuff, right? They can copy from our manual. How cool is that? And one thing that you might have not noticed is, for example, you can see this thing is, or maybe here it's visible more. Like, see, it's bold, right? So it's kind of like highlighted, and this sample to string is even a link, so I can click it, and it will take me somewhere. And I can have this or achieve this by, let me go to the sample demo. As you can see, I can say highlight, and this is the regex, so the thing I want to highlight in this line, right? Or I want to substring the toString with this target, meaning I will create this link for this toString. So yes, now the people who had their hands in the air for I'm writing Javadocs, you can keep them, the other can join, and yes. Is there a question or? Okay, no question. At least not so far. Yeah, so this is for creating, this very nice, snippets. Let me stop this. Righty. Are we warmed up? Are we ready? Yes, we are, right, because now we're gonna go for the more meaty stuff, right? And the more meaty stuff, like this was like kind of like perhaps a bit more trivial, but I needed to wake you up and show you that there are also like this tiny or smaller things, but they are also matching the ecosystem or the evolution of Java very, very nice. And now we're gonna talk about things which are covered by the preview features umbrella. Who's using preview features, or who had ever like used preview feature, or even on their machine? I would say not even a dozen of hands. That's why I have this little intro for you. So a preview feature is something like this. As we all know, Java has this philosophy, or Java team, let's try not to break things. Let's try to be as much backward compatible as possible. But if things go bad, like we will deprecate something for removal or remove things eventually, right? I'm talking like, for example, stuff like unsafe or whatnot. And for the new stuff, like first there's this new release cycle. So every 6 months there's a new Java version, right? And the thing is, like, and I really appreciate this. They want to throw some features at us, and let's ask the community, let's ask the industry, what do they think about this? How does it work with, I don't know, this library, that framework, whatever, right? So then we can opt in, like we can enable certain features, right? We can test them, we can give them a try, we can give feedback on mailing lists, we can be grumpy on Twitter, for example. So you can complain, I don't like it, or whatever, right? Yes, and how long a thing is a preview feature? It depends, right? I would say from my observations, it's at least 2 releases, which is 12 months, but it's not 12 months, right? It's 12 months from our perspective. From their perspective, it's like when it's this, this stage of code freeze or something, it happens like more or less 3 months before a release. So having something in 2 preview features, like we had switch expressions, for example, in Java 12 and 13, if I'm not mistaken, right? Then it became a real feature in Java 14. And they had like two rounds of feedback, and actually they used that. They changed things slightly in there. So yeah, this is it. Like preview feature may change, right? And if it doesn't change, they say you should be using it only with given Java versions. How does it work? It's implementation of JEP 12, and it actually goes down to this -- enable preview flag. So it's not about cherry picking features. You can't say, I want virtual threads, but I don't want structured concurrency. Okay, you can, because structured concurrency is it's a bad example. It's an incubator module, right? But you can't like say, I want this, but I don't want other preview features. It's all or nothing, baby, right? And versions must match. So if you are compiling with preview features, like for Java 19, even if they don't touch anything, and even if you're not using preview features actually, but you just compiled with this flag, it won't work on Java 20, it's guaranteed. It won't work on Java 12 as well, like because it's too old. So we have to use enable preview, and it goes for Java, Java-C, JShell. We have to use it in Gradle, in POM, XML, in IDE, and such stuff. So for Java-C, you have to go for enable preview, and you have to say which release you're compiling for, right? So we would say 19 here. And then, release is kind of like shortcut instead of setting source and target independently. And if you're using enable preview for Java-C, then release is mandatory. Like you have to use it. You can't say enable preview and like not specify version. You have to be conscious about which version of Java you're using, because preview features change between Java versions, right? And it emits a warning which can be disabled, so you can't say, oh, I didn't know about this. You've been warned, so you know about this. And it's written to a class version in Java file. So when you have a version in class file, if you subtract 44, right, you will get the Java version. So for example, Java 12 was, if I'm doing my math correctly, was version 62, right? And if you enabled preview features for Java 12, it was 66, because 44 plus 12 is 66, right? No, 56. How much is it? 56. Yes, 56. So it was 56.0 if you haven't used preview features, and it was 56.65 something if you were using preview features. So this is how Java-C and Java runtime communicate with each other, if it was using or compiled using preview features or not. How to set it in Gradle? You set it like this, right? You, for example, go for compiler options and -- enable preview for JVM args, and also for if you run your stuff from Gradle, also like this thing, righty. For Maven, it's like this. It's compiler arguments, enable preview, and for example, for Surefire, it's also enable preview. And for IntelliJ, if you're using IntelliJ, now it seems it's working okay if you specify this in an external build system, but if you're not using any, just doing stuff from scratch, yeah, please go to the project structure and then select the preview language level, right, in IntelliJ. I explained this like not in this room, but not in this T-shirt. This is actually a different color. But I was explaining this, so if you need like a deeper explanation, please go and watch this part of the video about preview features. So pattern matching for switch is a preview feature, right? And it's the third preview feature in Java 19. So they started in Java 17. Sorry, I think faster than I speak sometimes. Yes, so we are now witnessing a third incarnation of this preview feature, right? And it's implementation of this JEP. And most important thing, the good or switch, we all know. Also, like from the since like forever, like which is switch instruction or switch expression, which we know since Java 14, it stays the same, right? It shouldn't change. Your code should compile and work exactly the same. And if it doesn't, it means you found a bug in this preview feature and you should tell somebody. And it shouldn't be your dog, but someone who can actually address this issue, right? Yes, and we have this new thing. Please don't worry about this coloring. It's just JavaScript is not following, it seems, the new syntax of Java, right? And yes, this is it. This is it. This is it. This is it. So, am I able to fit everything in a screen? Yes. What is it going to print when I run this? Who says oops? Who says but why? But how? Who says impossible? Any other guesses? Let's see, right? I mean, in code we trust, so let's run the code. Like documentation can say everything, but when we run the code shouldn't lie. Hello, this is Java 19. Right? And we're gonna take this into pieces. So you can see a bunch of new stuff in here. Right, so switch can be now more null friendly. As you saw, we can have a special case for null, right? So previously we had there was this ceremony. So before switch, we had to check if it's not null, because if it was, it would go belly up. Right now, you can be more relaxed. You just go for case null, and you can handle null in switch, right? So no extra guard as this if on top of it. And switch handles now more than primitives, enums, and strings. That is the point, my friends. See, so I am switching over an object. This is an object, right? So I'm not using enum, string, or a primitive, right? And so-called dominant cases aren't allowed by the compiler. We'll get to that. And cases can contain guards. So this is a guard, right? It says when. In previous Java versions, if you're running Java 17, for example, in Java 17 or 18, it will look slightly different, because odds are you might be doing this in Java 17. So in Java 17 and 18, there was this syntax, end. Right? And after two previews, they decided to go for a special contextual, I would say, keyword when. Right? So this is Java 17 and 18, and Java 19 is this. Right? So it's using this when. So when it's, and for the case of integer, and when it's more than 17, we're gonna go and do this. So this is a guard, right? Or the guard, I don't know. And this is like, if we switch the order, then logically you would say, if we cover all these integers here, then what's the point of checking, like, if it's, like, how to, like, why should I compare it to any number? It doesn't make any sense. I got here, right? I got it here. So this is, as you can see, this case or branch in this switch dominates this thing. That's why it's called now dominant case, and that's why it has to go after, right? Yes, and sealed classes don't need defaults. Sealed classes are a very neat feature of Java 17, I would say. And pattern matching doesn't work with primitives. So old stuff still works with primitives, right? Old instructions, switch instructions and switch expressions, but pattern matching doesn't work with primitives, at least not now. And switch instruction works with PM2, so it's not only about switch expressions from Java 14, it's also, you can like use it with the good old switch instruction. And pattern matching doesn't allow fall through, meaning you don't need to have these breaks, because by the default they're like not needed, right? So we have more sophisticated demo for this. Let me go back, and now we should have this switch pattern matching. Yes. And about this when, it's a very nice thing. You can have a code like, it's not my invention, it was inspired by Dmitry Alexandrov. Now you can have something like this. Right, so when w dot when, then yes. So this is a valid Java code. It works. We can let's see if it works. It should work. Yes, but this is like more like a side joke. Okay, even so. This is like a lot of switches we're going to see now. Any electricians in the rooms or network engineers? Okay. So as you can see, let me run it. Let me run it first. Let's see if the code not only compiles but also runs. Very nice. It compiles and it runs. Hopefully it will also run on your machine. I mean, it should. Why it shouldn't? So switch instructions remain. The ones that we had from Java, like whatever, like Java 7, for example, they're still the same, so we can switch on things. And if we try to, so this is it, right? So these are the constants, right? And if we try to switch over a null, IntelliJ is already warning me, right? But if we try to do this, you can see if it runs, that it throws null pointer exception because I don't have this if check on top of it, right? And so also this switch, sorry, I could say expression here, expression, if I'm not mistaken. So that switch expressions keep working the same. See, this is switch. Oh no, sorry, I was right. This is switch instruction only using this arrow/lambda style, right? So they also work the same, nothing changes here. So since Java 14, you can also write switches like this, right? Very nice. And what we can do now, it's now switch can handle nulls. And I like it a lot because switch instruction with null and everything. So as you can see, for switch instruction, you can have like special null case. Let me run it so we can, oopsies. Oh, wrong. Okay, I was correct. Yes. So, sorry, I got lost in my own code. Like, I wrote it more than a week ago, so it's all legacy code. No worries. Where were we? Yes, switch instructions with null. So as you can see, if it's null, it will also print null, right? And switch instructions with null or default. So this is nice. For example, you can combine null and default, right? So it's not that you have to have like separate case or branch, so to say. You can combine them, and you can also combine them with something else, right? So you can have like a standalone case, right, like this, for example, for switch expression, or you can also like combine it, like if it's empty all null, you're also okay. So it's empty all null, right? Very nice. And yes, and then we're gonna go switch over. That switch can handle now different types, as you can see. So I'm switching over an object, right? And where is it called? So I'm gonna switch it over a halo or 42, so integer long, an instant, and an array of doubles. And as you can see, this is what actually happens, right? So when I'm switching over it, so then it selects if it's a string, an integer, a long. So I couldn't use long because there's a keyword for this, right? That's why it doesn't work. This is why it's a long, or I should maybe call it Josh long, but I don't know. Anyway, yes, and now we're gonna, so this is like, I would say, pretty easy stuff. Now we're gonna go for these dominant cases, right? So if I'm switching over an object, and if it's serializable, I'm gonna write you're serializable again, right? And now if I try to go for a string, I can't do this, at least in this way. Why I can't do this? I can't hear you. Strings are serializable. Exactly. I'm sorry, sir, you already have your jellies, so I won't give you another one, right? I hope you don't mind. But for other folks, I still have like some jellies from Poland, so if you fancy, just be a little bit louder. Yes, that's it. So if I want this to happen, I need to put it on top. So this case isn't dominated by a serializable case, right? And so the same applies for to integer and to long, of course, right? And then we have this default case, and we can also now go for switch with patterns. So in Java 16, we have this very nice thingy. Let's see if it works. Yes, it would work, right? So I could go, so if you are a string, then I could alias it and check if this length of the string is more than 3, or at least 3, sorry. And then I would write you are a string at least 3 characters long, and so on. And so this was introduced in Java 16, right? And now we have the same thing. We can do this with pattern matching. So we can go for this, for matching the pattern. This is it. So this is where the name comes from, actually, for this thing. So yes. So as you can see, if you are a string and you have at least 3 characters, and we are going to write this, right? And oopsies, debug. And this should be, yes, this is it, for example. We're in this area, right? See, you are a string at least 3 characters long. A positive integer, a long that has only 1 digit, right? A double array where the first element is 5.0, right? So we can match even this. And then, of course, you're something else, right? This was an instant. This was this something else thingy. And yeah, so with pattern, okay, so these are the dominant cases. So, for example, can we or can't we move this below? I'm not sure. I might have messed something here. Yeah, it seems like something got moved here. Anyway, let's go then, and there should be also one thing with sealed classes, right? So we have these sealed classes, and basically, when I have sealed interface, well, maybe that would be easier like this way. I can go for permits, final class, record, and non-sealed class, right? If they were in separate files, this would have to be like this with permits, but since they're in the same source file, I can skip the whole permits clause. So it means that the sealed interface can have only 3 descendants, so to say. This final class, this record, or this non-sealed class. There is no other way to create something else, right? I mean, in another child class or interface. And therefore, because of this, as you can see, I don't need the default. And even IntelliJ is smart enough to tell me, look, this default doesn't make any sense because it's not needed, because your sealed interface can be either final class or record or non-sealed class, right? So the compiler is, and also IntelliJ is smart enough to do this. And as you can see, we cannot use primitives for this pattern matching. It won't work. So these are constants, right? So this is the good old way. This works. This doesn't work, right? And what works is autoboxing. But should you use autoboxing here? I don't know. Like, it's up to you to decide. If the penalty isn't too much. And of course, yes, this also like switch instructions. So you can see it's the instruction that we know since like forever. It's also can handle patterns now, or pattern matching, no problem with this. As you can see, it works like this. And yeah, we don't need the break here because there's no fall through. But if I don't have a break here, it doesn't compile. Why it doesn't compile? Any wild guesses? Don't be shy. Yeah, it goes into like this, right? Because then if it's if I have something given here, right, this sealed interface instance, and then it got matched here, and we would print it, and for here, then I can't access this R and what is this NSC, right? It's something totally different. That's why if you go for switch instruction with pattern matching, you have to be careful about the breaks, right? Basically, it tells you, give me a break. Yes. So this is needed, and this isn't needed because this is the last one. And I think we are done here. Any questions to pattern matching with switch instruction? Yeah, so these examples, I would say, are over-engineered. Like something like this might be nicer when you're not sure what you have and you need some guards. Question? Yes.
What about pattern matching with regular expressions?
Like regular expressions like regex?
Yeah.
I think they're trying to solve one problem, not introduce another. I'm sorry. I mean, this is like a joke, but yeah, I guess it would work. Yes, why not? If you had like a string here, right? And we can go to another, like, do we have like string? Where was this more than 3 characters? Here, right? And if you here create regular expression in this regular expression matches, then you will get in here, of course. So this thing has to do what? Resolve to a Boolean. True or false, yes or no. Enter, you shall not pass, right? If you can squeeze your regular expression here, right? Why not? It will work.
I want to extract something from a string using a regular expression and have that as a variable for...
So here in this scope, you can use this string as well. So we can use everything that's available here. So we can go for like, I don't know, int, let's say, mean. I mean, it doesn't make any sense what we're doing right now, but we can go, for example, like this, right? Plus mean. So as you can see, it also, because mean is in scope, right? So we can use everything which is in here, and the string happens to be in this, this thing happens to be the scope as well because it's aliased here, right? So this is the alias for the thing we are matching, and of course you will also get the object here, right? So if we had like also object hash code, it will also be here, right? So everything you can put here, everything that you need, right? You could also then extract it to you see to oopsies, another shortcut. How is the IntelliJ crashed? Very nice. Will it work like extract method? No, it won't. It crashes. I'm using the EAP version to have support for Java 19, right? But you could have basically a Boolean here, and when this is true, you get into here, right? So if you can make regex go here, it will work here, as far as I can tell. All right, let's keep on moving then. Record patterns. Preview feature in Java 19, JEP 405. And again, the type patterns, the things that we just saw, and also the one working with instance of, works the same. It doesn't change. It's they're not touching it in this JEP. What we're doing here is something that would allow us deconstructing records. Who's been working with Scala? A few people, okay. So in Scala, we have this unapply method, right, which is used in pattern matching in Scala. And here is like we don't have unapply method, and right now it works only with records, but it's since we have canonical constructors for records, we can also have canonical slash inferred slash, I don't know, well understood deconstructors for the records. And this whole pattern matching, record patterns support nesting. And for now, there are no other types, meaning we can't create sort of like our own unapply method. We have to rely on records only. And it works with ifs and switches. Righty, so let's go there and We should see it somewhere. Is it okay? It's Java 18. So now let's go for Java 19, and we should have these record patterns, right? Record patterns demo. Very, very nice. Let's see if it runs, because running stuff is usually better than just compiling stuff. Okay, very nice. Very nice, very nice. So what we're doing here, we have this, shall I say even function, because it's a starting thing, give me something, and it gives us something. And if this something is a value, and of course we have this value is a record, right, which can take a double. And or we can have like a complex number, which can have two values inside, right? So if it's a value of double, we will have the value. If it's complex, we will see the complex. Here we didn't get anything because apparently it wasn't a value or a complex. And we got here because we have was ist das? And this is like one of the quotes from one of the Polish series. Kapusta und kwas, so cabbage and some acid, I would literally say. Anyway, a little bit like a Easter egg. So here you can see how we can value things, right? Let me run it again. Sorry, not value, but like deconstruct things. Oh, now we got the complex. Very nice. So, very, very nice. But let's see if we get like a value, perhaps. Oopsies, like wrong code, not you. I want you to run. Yes, and now again, I'm looking for the value. Yes, okay, we got the value. So we got the value, and as you can see, I'm now saying not just instance of value, but I'm like using this double V inside, right? And when we go to value, you see that I'm using value here, and here I can just have V. So it's like the names can be different, right? You could say Yabadabadu here, if you please, whatever, right? And then we can just say I got the value. See, so I got the double at hand. I don't care about the whole record. I just deconstructed this record, like, and extracted what I needed, and I'm using it here. I mean, this value kept inside. And now when we go for, now I need a complex. Come on, random, behave. Now, okay, now we have complex. So I can go, when I have complex, I can go for value R and value, like real part and imaginary part, like the complex numbers, kind of like 2D numbers. Just a second. And then as you can see, I can like match them, so R and E, and I can go for R value and I value. Or I can go deeper, right? We have to go deeper. So then we can go like this. So it's a complex of a value with double R and double I, and then I don't have to call these values because these are like given to me. There was a question.
Is defining the type required? Because the compiler can infer that.
Like this double?
Yeah.
Okay, let's see. Like you mean something like this? It doesn't work. Right? I like your question very much. Let me throw you some jellies, because that's like actually requesting my next. Sorry, almost there. I didn't throw them. Like I might be better at throwing exceptions than jellies. Sorry. Anyway, yes. So apparently we need the type, right? And let's comment this thing out, righty, and let's go for this thing. Give me generic complex, and now I have this generic complex, right? And this is like over-engineered, right? Why is it? What's your problem? It works, and it's like sealed class, but we do have subclasses. This is like a glitch in IDE, I guess. Don't worry about this because it still works. Right. So we have this generic complex in a way which can use anything for a real and imaginary part, right? And now, in this function called give me generic complex, I'm gonna return a complex that either has integers, right, or doubles, or integer and double and integer. And then, if by any chance I go outside, it would throw unsupported operation exception. I mean, I shouldn't because it's 4, but the compiler doesn't know, so it will yell at me, right? So this doesn't work, so there is no like, you know, sophisticated like dry runs if it's really like mutation testing or whatever, if it's not going to exceed 3. Anyway, we have all these possible combinations of complex, right? And now, as you can see, even when I go for the number here, right, I can match if it's going to be integer and double or integer and integer, and then I can go for something more like number and double and number and integer, right? Because maybe, I don't know, but just by looking by the number, it could have been like a byte or short, right? Or a long, I don't know. And as you can see, they also support dominant cases here. So this doesn't work because if I have number and a double, then of course this is more generic or wider, I would say, than having integer and double, right? Because number is wider than integer because integer inherits from number, right? Or implements it or something like this. So I guess that's why we need these types here, and I don't mind it, and then we print everything here, like what we got and everything. Let's see what we got. I mean, this doesn't make much sense in terms of mathematics, but it's like illustrates the, you know, dominant cases, extraction, and like types and everything, right? So as you can see, now we got an integer and a double. So integer and double, yeah, so it's the first case, right? And if we rerun it, it's a double and an integer. So now we are in a double, not here. It could have been here, but no, it's integer, so not here. And now we go for this, yes, so now we're in this branch, right? And we can go for, give me sealed generic complex. And it does similar thing. It's just now I have a sealed interface. Now see, suddenly it's not red. Okay, very nice. It's the sealed interface. It means it can have only implementations listed in this very file. So I have D value and I value. Please excuse my bad naming choices. As we know, it's one of the hardest things in IT, right? Naming things. So I failed here, but I hope it still stands the point. The point, like I can have double value or I value and nothing else, right? Nothing but these. So then when I have give me sealed generic complex, again, as you can see, this is like this generator, right? Only I'm wrapping it into an I value, D value, and everything. So there's like the whole permutation, right? Whatever is possible. And then when I go here, let's see if it works. It should work. Come on, yes. And you can see I got I value and D value. So this is I value and D value, so again, the first branch. Now, have you noticed something peculiar about these two switches? Sorry? Yeah, who said that? Yeah, I'm sorry, I can't throw it that far. Would you like some jellies? Yeah, so you come and grab some, right? Okay, yes, it's very nice. I hope you don't make this off by one errors because you've spotted that instantly, right? So here we have 5 lines and here we have 4 lines. Why? Because if I don't have this one, it will complain that I'm not, that the switch is not exhaustive, right? So it doesn't cover all possible option. So even if I know that there is no chance because I'm only generating these 4 things, it sits in my brain, in my head, right? For like 2 seconds, and then I forget about this. And we all do this, like this. That's why we need this number, or I would need this case default, right? To like handle, like to make like this switch complete so everything is covered, right? And because we are using sealed classes here, the compiler can check like, okay, it's like, if like, basically this covers every permutation. That's why it doesn't need this number, because even if I get like double, it's gonna be here, right? And if I get double I value, it's gonna be here, right? So every possibility, every possible permutation is covered here. That's why there is like 4 lines here, or 4 cases here, and 5 cases here. Doesn't make sense to you? Yes. Okay. Very nice. Sorry, doing some math because I think we might want to have a break at some time. Rollback, very nice. What do we have more in our slides? And this is it. So, foreign functions and memory API. Do we have some C beasts in the audience? Golang beasts, C++. Okay, not that many. But sometimes there are things that you want to call from the native stuff, right? Or sometimes you don't want to be garbage collected, or you don't want your region of memory to be managed, therefore you want to manage your memory on your own, right? And this is like, there are ways to do that in Java by using snippets, JNI, and everything, but these are like dangerous or slow or everything, right? That's why Project Panama is like, if I'm like, it's complicated. It's like this bold and beautiful. Let's see. So as you can see, this is the whole history section. So it shows that it combines early incubating API. So these were these JEPs, and they were like coming from another JEP, which in case like so there was like a 4 incubators in past, and then they got combined or something like it's like, yeah, it's like soap opera. Anyway, now we have a single JEP, which is a preview feature, right? And it is about doing two things. So allowing us to call foreign functions slash thing like native stuff, right? So we can call native stuff, native functions, and that we can also handle native memory. Right, and it should be like a proper standardized way how to do this. So it is about avoiding this foreign memory access. It's about avoiding limitations of Java NIO byte buffer. For example, you can't go for bigger space than 2 gigabytes or 2 gigaoctets, if you speak French. Yes, and it should be safe and documented, unlike snippets, and should perform not worse than JNI, and hopefully better. Right, so that's the whole point about this. And there are some building blocks of this foreign memory access, and these are memory segment. So this can be like a chunk of memory, right? So you ask like, I want to have this memory. By the way, memory in your computer is not two-dimensional as they picture it sometimes. It's linear, right? Because I have just one address in memory, so it has to be linear, right? Or we can have like an array. To be accessed this way, and then we can say, yes, this is like this address, so I want like to start here or start there, something like this, and there's the memory layout. So it like you can say, okay, in this memory segment I'm gonna keep ints or longs, or I'm gonna keep like in C, or if you happen to work in Go, you have structs, right? So structures. And the structure can be, for example, one integer and one boolean. So we can say my layout is like an array of these structures, and each element is a structure that has an integer and a boolean, something like this. And yes, and then we have memory sessions, so it's about setting boundaries for time and thread. So I can't use it after, and I can't use it, for example, in another thread if I don't want to, and it works very nicely with try with resources. And we can also use var handles. Yes, demo. We should have a demo for this. Right, I don't always demo, but when I do, right, there's a separate module. Okay, very, very nice. And foreign memory access API. So first, we're gonna do stuff in the same thread. Righty, so let me run this thing. Let's see if it works. It does. It doesn't do something particularly fancy, but what it does. In the same thread, I'm asking like memory layout, give me the sequence layout of 10 elements, and these elements should be or have the value layout of Java integer, right? So I'm gonna to allocate 10 Java integers of heap. So this shouldn't be like touched by garbage collector, right? I mean, this thing inside. right? So this is the layout. And then I'm going to allocate this. So I'm allocating here. So saying allocate native, and this is what I want, and open implicit. So this is, as you can see, this memory session, meaning that all threads would be able to use this. And now I'm going to populate this memory segment, and this is how I can do it. So I can I would say the easiest way, at least for me to understand, is when I have this segment, I say that at this index, I want to say thing that has this layout, right? And so this is this index, and this is the value I want to set. It just by accident they are integer at the same time. Or I can use the var handle and then go like this, right? I can say, so in this segment, that may be even easier, because see, for this var handle, I'm already saying that this is the int array layout, so it's using the layout from this sequence layout that was given from above, so I don't have to like duplicate thing, right? And anyway, I'm just storing 10 elements, because this is the size of my layout. Should we go, for example, for equals? Let's see what happens, right? Let me see what happens. Let us see and experiment a bit. And see, it says, come on, out of bound access. So you asked me to allocate 10 ints for you off heap, right? And now you want to set 11th. Come on. This is what it does, right? So as you can see, I'm safer. I'm sure I'm not overwrite somebody else's memory, right? Or if I like have a bug, so the attacker can't use it. And then what I'm doing here is I'm looking into this memory to see what's in there. Okay. Yes. So this is the memory address, as you can see. So I got the address, and I'm looking at who's the owner of this session. So because it's open implicit, there is no owner, right? So everyone can own it. So it's kind of like a shared for everyone and open like for every thread. Okay. And then I can either use var handle, like in here, or I can go for then. Like I had this set at index, now I have get at index, right? So I can get what's like Java int at this index, or I can say that this item handle from this segment is at this index is this thing. And so it repeats. See, so this is the first thing, and this is the second thing, and I have this space in between. So I wrote something to this memory, and then I read it back. Right, and I could use it to communicate, for example, with the C process or something like this. If it gave me, for example, this address, and I knew the layout, I could also construct memory segment, right? And basically we could like, I don't know, have a producer and consumer exchanging data by this memory or whatever. Or I could like memory map this file and stuff like this, right? So as you can see, it provides us at least this space boundary. So I wasn't able to go beyond. Let's see if I'm able to go beyond here. Right, again, less or equal. Command run, again, the same, out of bounds access. So it's safe that you won't go past the memory segment that you have allocated, for example, or that you created if you're doing this from like hand or from scratch. Let's do one more thing. Now let's try to see how two threads can work here. So I'm doing the same thing, more or less. Now I'm going to use open confined. So I'm opening confined memory session, meaning, and it's very nice with this try with resources, as you can see. Now I'm saying that it's going to be confined to this thread or which created this memory session, right? So again, I'm populating this, I'm examining this, and this should work. And any ideas what will happen when we look at this code? I still have some jellies. And even like 2 candy bars, okay, sweet bars, like if you wish. Yes, what kind of exception? Yes, very nice. Would you help yourself here at the table, okay? You're quite far away. All right. So, yes, It would do something like this because this is an abuse of try with resources pattern, right? So I'm trying the resource and I'm now closing it explicitly. So here it should blow because it's already closed, right? So it's not accessible. Yes, exactly. Like illegal state already closed, right? Unfortunate. Okay, but how about doing this? You see, now I'm creating another thread, right? And in this thread, I want to, and I even like call it, it's a reader thread, right? To be explicit. And in this very thread, I want to examine this memory, the segment that is possessed by this thread running this, right? So let's go. And you see, attempt access outside owning thread, right? So, as you can see, there is a proper API, right? This is not like I'm calling, so I don't know, dynamic stuff or feeding with feeding C with this or something like this. It's like what I have to do. This is a proper Java only API, and it's safe that it doesn't allow me to go beyond, right? You're supposed to be in this zone, you have to be in this zone, right? Then it has this time boundary. So if you close this, you said you don't want this anymore, so you don't have it anymore, right? So this is this session close thing. And then it's even like, it's me, only me. This thread is going to manage this, right? So no other threads can access this. So this is what it means, safe. In this case, right? So we, the developers, don't do stupid things like we don't leak references to other threads and so on and so on, right? And like don't go for this famous, like some time ago, string or strcpy method call or function call from C++, right? Okay, let's finish with this foreign linker API. And then I guess we'll take some short break. Okay, so foreign link and API. The other thing that's also combined this into this FMM preview feature. So it's about replacing JNI with pure Java development model. So we don't have to create any, I don't know, like stubs or whatever, or like create some classes and some generators and like, it's like, again, it should be Java only, and it should allow us calling native stuff, right, or foreign stuff. For time being, it supports only C for AMD 64 and AR64. Like, I guess that means Mac, Mac's M1, right? But only C. In the future, they might also extend it to support other languages like C++ and other architectures like 32 bits, for example. Right? And again, the performance should not be worse than the one of JNIs, hopefully better, right? I didn't write any benchmarks for this. I have other people who do this. And it relies on the concept of a C-linker, and it allows two things, so-called down calls and up calls. So a down call is, from Java, I want to call this C code, right? I will call this code, and this code will do something and handle me a result. And I can do so-called up calls. And the up calls are like this. For example, in C, and this is like it's so cliche, but I think it's the best example, so I didn't invent anything better. So in C, I have written super efficient sorting algorithm. It really sorts things very nicely. It's just, it doesn't know how to compare two given elements. Like, it doesn't have the comparator, if you will. So the comparator I have implemented in Java. So now I'm going to call this C code and give it the like a reference. Like, see, here is the comparator, use it. So I'm from Java, I'm going to call C, and then C is going to make the up call to this comparator, right? So this is how it works. And you might say, like, why so much ceremony? Why is it so different? Like with this whole like foreign things, JEP, and why are they doing this for like so long? Like, I don't know, like 4 or 5 versions, and it's still not a thing. I like it very much. because it's going to stay with us for very, very long, if not forever. That's one thing. And the second thing, it's really not trivial, folks. Like, think about this. C is not garbage collected language, right? And Java is garbage collected language. So we need kind of like a layer or something, like when, for example, C wants to call stuff back again, right? Suddenly it might be in a different memory region. Not easy, right? C is not aware of this, that things are moving. Like once you malloc, it's there until you're free. So, and like relocations performed by Java garbage collectors actually do that. They shuffle stuff in the memory, they compact and everything, right? Even concurrently these days. So, I shall have a demo for that as well. So, yes. Again, a bit like cliche perhaps, but it works very nice. So, I'm going to call the UID. I'm gonna get the user ID of the user who's running this program. And for this, I'm gonna perform the native call, right? And the logic is this: if I'm gonna write like what's the UID of the user who's running this, and then if it's root, I'm gonna say nada, right? I don't want to be run as root. And some people might tell you, and they don't even live that far away from here, that running your Java stuff as a root is in general like a bad decision. So why not encode this into our program, right? And we have this, as you can see, we have this native linker. So we get the native linker, and I'm now going for the default like standard library. And I'm looking for a get UID function. So this is basically this function described in this man pages here. If I can't find it, I will throw I can find it, right? And then it should give me Java short, I guess. And so this is the function description, right? So I'm going to call this, and this is function description. So it's like what it accepts and what it will give me as a return type. Basically, cannot think of like signature, right? It's a bit of a simplification, but it works for the demo. And then I'm using this native linker, right? I'm going to perform this down call. So I'm going to call this thing, which is described like this, right? And then I'm going to get the value, and after I invoke this, I'm going to cast it to like a log, for example, and we'll see what UID will I have. And now, normally, I run it just like this. I was running this, but then there are people who don't have this library working, or you don't have Linux or something like this. So I would like to test it. So how can I test it? We can go for the. I'm sorry. I'm working for a testing company in a way, right? So we're gonna do integration test for this using test containers, because what else, right? So. We're gonna go and fetch the Eclipse Temurin image, and then I'm building this thing. So let me go for how is it called? Is it Maven? How do I build the artifact? But it should be there, right? So I'm going to copy this jar, which should be in target. Yes, it's here, right? I'm going to copy, and then again to make it wait, I'm going to call this wait server, and I will start this container running Java 19 on Alpine, right? And then I'm gonna execute in this container Java with enable preview, because it needs preview to be enabled, and this is going to be the jar. And I'm going to assert that the exit code is not 0, because as you have seen, it will return 42, right? It is a very nice decent random number. And then that the standard error says something that you cannot run me as root. So let's see if it works. Very nice. It works. Right, so I have in test now for covering this. So I really encourage you to test your stuff like this. Don't run it locally. And now, even if you don't have Linux, you can still use test containers, and as you can see, then you have Linux, right? And if you don't have like a Docker and you don't know how to run this, because it happens that I also don't have Docker installed or running. As you can see, my Docker is dead. So just as on Windows, you might not have Docker. I also don't have it running right now. Please go to Oleg Shalaev's talk on Thursday. He will explain you what's the magic behind this, right? There's no magic, just a solid piece of engineering. Yes, so any questions to this foreign stuff? I don't see any. Okay, very nice. So, sorry. Yes, so, okay, it's 11. We have been sitting here for 90 minutes. So how about having 15 minutes break? So we meet at 11:15 and we continue, right? Okay, see ya. And it's gone. I mean, the break. I hope you managed to grab some coffee or another beverage. Let's keep deep diving on new stuff in Java 19 in this case, and it's going to be about virtual threads. And yeah, it's a long thread on its own, isn't it? Right, so we've been like Project Loom. I mean, we keep hearing about Project Loom for quite some time, and here it is, my friends. So it is a preview feature of Java 19, right? So officially, it's like in the builds, like regular builds we have, not just some special builds, as JEP 4.2.5, and it's a very long JEP to read, right? And therefore, I guess there was another deep dive just on Project Loom yesterday morning, right? So we are not going to spend 3 hours on virtual threads, yet just for sake of completeness, we have to mention at least something when it comes to virtual threads. So yes, what are they? So, and what this whole JEP is all about. It's about keeping concurrent and current actually threads model as it is right now. So nothing should change when it comes to the threads we already have, and Java still should be, like concurrency, Java still should be built around the concept of a thread, right? As such. So yes, it's also about allowing to have this nice pattern or usage scenario or idiom, whatever we call it, which is thread per request. So Java is more than 25 years old, right? 27, if I'm not mistaken. Maybe I am, I don't know. And threads are with us since the very beginning. That's why we have, for example, this wait and notify methods in an object, right? So some changes might not have been fortunate. And hardware and the usage and how the world looks and technology looks has changed over these years, right? Over these decades. So I remember the times when it was really like great news that, for example, on Windows, Java finally started to have like a proper threads, right? And how the threads work in Java, and now we call them the platform threads or the OS threads, is just they are managed by the operating system, right? So back in the day, how, for example, the servers worked was more or less like this. There was a new request coming. So the server started a new process. It was handling this request in the process, like in the CGI bin or whatever, and then it was like giving the response and the process was terminated. It's just starting processes is heavy. It's heavy as in heavy, basically. So then there was the idea of threads. So threads were supposed to be much lighter, much faster. They were about to cost less, right? And fast forward a few years, and we ended up in a situation when threads are costly, right? Because we have these many microservices. They're interconnected, right, together. They integrated that much that you have like several network trips and so on. So starting a thread for everything, again, it's painful. Plus, we don't have an infinite number of threads per machine because they are like depend on the operating system, they depend on the hardware, so we can't escape from this. We can tune that, of course, we can squeeze the lemon as much as we can, but it's like there is a limit. That's the bottom line. There is a limit, right? And this virtual threads is about to have this go back to this thread per request approach. It's going to be different threads, virtual threads, not the platform or OS threads, right? And it's also about providing some debugging, troubleshooting, profiling, and everything capabilities, right? So it's not just, have these virtual threads and be happy about this, but so we can also take thread dumps and see like some statistics, for example, with when they are pinned and stuff like this. So we know when things go wrong, basically. And it is about improving scalability for the asynchronous style of programming. So our programs, our systems scale better. And I would say this is the most important thing when it comes to project Loom and virtual threads, or whatever the current name is. I mean, the current name is virtual thread, but there was like it was an idea to call it fibers and everything, that every thread should behave like this, like by default. Now it's like whatever you had so far. If you run your current program, it will work like this, and you can opt in or start migrating your code to utilize virtual threads. And they made a lot of effort to make this migration as easy and as much without pain as possible, right? But like a lot of people think that virtual threads somehow magically will let you compute more. Okay, so let me put it this way. Just because you install Java, let's say 19, and you go -- enable preview, it somehow doesn't add transistors or more silicon chips to your machine, right? So it won't come out of the thin air that suddenly your system will be faster. It's not the point. Like, so if your system, your application, your program is computation heavy, it's CPU heavy, it won't change much, if anything, right? So it's not about squeezing more juice from your CPU, from your silicon. It is about unmounting, right? So who's familiar with the concept of coroutines, go routines, stuff like this? I see some hands in the air. Yes. So it's like what they do, these virtual threads that they unmount from carrier platform threads when they are parked. So let me use this metaphor of cars, right? I mean, for mounting and unmounting would be perhaps better to use a horse, but I don't know, maybe cars are more modern stuff. So you have your own car, right? Or you have like a taxi, right? And you're driving, for example, you asked a taxi or Uber or whatever you please to take you, like, for example, from point A to point B. And then you have to, I don't know, you decided I want to have a lunch, right? And it will take me 1 hour, like, because I'd like to meet with my friends and everything. So with the platform threads or OS threads, you just have to park your car next to the restaurant and it's waiting there for you for 1 hour, right? And it's basically, in that term, it's a waste of hardware resource. But if it is a taxi, for example, or this car sharing, you can, for example, tell the taxi driver, drop me here, right? And I will call the taxi company, or I will order the next Uber ride when I'm ready to go from restaurant to my home, right? And then we are kind of like not wasting this resource. The resource can be doing other stuff. I don't know, carrying other people. It can, I don't know, deliver pizza, whatever, right? And this is it. So this is this shift. When we are waiting for some data because we have to read file or we have to wait for a network response, for example, in a platform or OS thread, we have to wait, and the thread is still occupied waiting basically and doing nothing productive. And the idea of virtual thread is that thanks to so-called continuations, is that the virtual thread can unmount the platform thread. It's say, okay, I'm gonna wait for the data, so you can go and handle another virtual thread, right? And you can carry another thread. So another virtual thread can mount you, right? And use you. And this is happening through the usage of the fork join pool. So this is what's happening, under the hood. And it's like a FIFO style and everything. But like, let's not perhaps go that deep. So this is the idea of virtual threads, right? And they do unmount unless they are pinned. We'll get to what pins means, or I can tell you like already why not. So there are operations or situations when virtual thread can't say, okay, you can safely drive away. I will call for another platform thread. And such a situation is, for example, when we are making a native call, right? So currently, like if you're making like native call, like we did, for example, previously with this linker API, the platform thread will be still used, and therefore it will be called as so the virtual thread is pinned, right? Another situation is when we do this waiting inside synchronized block. So right now it's still pinned. Maybe in the future it won't be pinned in such situation, right? And if you like to trace this situation that you don't have the pinning after you migrate your code to use virtual threads or Project Loom, you can go for this switch JDK threads pin threads, or you can watch for JFR events. Like you may need to enable some. Right. So let's go to the demo. That should be Java 19, right? Yes, here we are. Okay, concurrency. Has anyone played with Loom before? Okay, not a single person. Very nice. We're in a good room. So, virtual threads. This is more or less this. Of course, there's a new API, right, around virtual threads. So how do we create a virtual thread? You cannot go for like new thread and like switch a Boolean flag like virtual or platform thread. We go for a thread of virtual, right? And then we can go, for example, for start if you want to start it immediately, or we can go for unstarted, right? And then we have to set started later. And there is, as you could have seen, it is runnable, right? So I have to provide runnable just as for a regular task, right? And what I'm gonna do here, like let's run this and let's see what it prints. Righty. Okay. Very nice. Okay. So I can check. I'm not sure if I should do that, but the API allows me to do this. So I can see, as you can see, I can get the current thread, and I can ask the current thread, "Hey, am I virtual or not?" Right? And in this case, it will tell us, "Yes, you're virtual." And we can get the current thread ID. This is a new method since Java 19, as you can see, or you can't because it's this small. Yes, so it's Java 19, and the other. This old one, get ID, sorry, got deprecated since Java 19, as you can see, right? Yes, it shows this deprecation here. I forgot. And then I'm asking, are you a daemon, right? There's nothing demonic about the threads. Like if you don't know, the thread can be a daemon or not, and basically the difference boils to this. If a thread is a daemon and we have only daemon threads in our JVM, right, in our process, then the application will stop. Meaning I can have 500,000 daemon threads if there's at least no single non-daemon thread, like apart from the garbage collections and everything, then my application will stop, right? So as you can see, this is a daemon, and I can use another method which would be off platform, if I'm not mistaken, and this should give us the regular, or the platform thread. It's not regular, like both are regular. Yes, and as you can see, it's not virtual, and it's by default it's not false, and it still has like threads ID 32 because apparently this when this program starts, it happens to be 30, like a thread with ID 32, and these threads are no different from, or should be no different from applications point of view, right? So if you like run something in a thread, and that thing shouldn't be concerned if it's a virtual thread of a platform thread. They have separate stack traces, they have separate thread locals, and everything. Basically, if we are calling a virtual thread, it's a virtual, and it's like the passenger or the rider or a thing mounted on the virtual thread, but there's like a separation between them, right? So one doesn't know about the other, meaning that, for example, your operating system, if you do like a thread dump, you have like in Linux, right? You have these things to do like thread dumps and everything. They are not aware of virtual threads. As such, this is solely JVM concept. So now, because these platform threads are one-to-one mapped with the operating system threads, that's why I sometimes like interchange the name, right? And the virtual threads, for virtual threads, that's not the case. Right, that's why we can have this M to N relationship. Basically, this is how it works. Righty. So now I should put here, maybe for the sake of like future readers, this will work different on your machine. So the numbers that we're going to see and evaluate here are kind of like they will differ on your machine, right? So I have like a Intel i9 with 6 physical cores. I don't know which version that is. I don't remember. And I have certain amount of RAM and everything. So this is like, and I don't do in these demos. Like first, they're not proper benchmarks, so please don't tweet Alexei Shipili of like, look, these guys like not doing proper benchmarks. These are not proper benchmarks, right? This is like most naive approach. We're just simply going to run our stuff without any other pre-configuration or tuning or anything like us regular developer could have started their journey with Project Loom, basically, right? So any numbers we're going to see now, like latencies, delays, durations, whatever, are just not scientific thing, right? So what we're gonna do in this little demo of ours, so we're gonna capture when we start, then we're gonna capture when we stop, and we're gonna print how long it took, right? And then I'm gonna try initially for 30,000 threads, right? So on your machine, this number will be different as written here, right? And then I'm going to create a thread, right? And then I'm going to start the thread, and every 5,000 threads, I'm going to write that I'm by this number, so we see how many threads we have. And yes, so how do I create threads? So initially, I will be creating threads like this in this good old-fashioned way. So I have like a runnable, right? And this runnable is a blocking operation, and this is this kind of like sneaky sleep. So I'm gonna sleep for 10 seconds. And one of the changes of the API is now we have two sleep methods. They throw exactly the same exceptions, and they should be avoided in exactly the same way. Again, this is like a demo, right? If you have sleep in your production code, I would suggest you are doing it wrong, right? You should go for like reentrant logs or whatever. We'll get to that. And as you can see, I can have sleep accepting long. So this is the one that we had so far, right? Since like ever. And we also have the sleep that is using duration, right? So as you can see, it's it's a new thing since Java 19. So if you have now duration, you can go for duration, which might be easier if you like have issues like multiplying like 4.5 minutes, how many nanoseconds it's gonna be. So maybe it's better to create a duration object, right? Anyway, we have this sneaky sleep, and I call it sneaky. Like in Lombok, we have this sneaky throws. That's the whole reason. So I basically convert this exception. That's the whole thing. Don't do that, apart from demos, right? Where were we? Yes, so this is this blocking operation. So this blocking operation is going to block me for 10 seconds, right? And I'm creating new thread. So these are going to be like a good old thread. So except for this sleeping for a duration, that would be the same code as we run in like Java 18, 17, and so on, right? So let me start this thing and let's see how it behaves. What does it do? Right, 15,000, 20,000, 25, 30. And it's running because even the latest thread or the last thread still needs to work for or sleep for 10 seconds. That's why we have this delay of 10 seconds, but I was able to create 30,000 platform threads, right? Now, if we get rid of this, so I'm not joining the last thread, right? By the way, this is not how I would suggest you to use virtual threads, right? We will get to the next step of structured concurrency. I would say that is the preferred way of using virtual threads, but we're using this for like deeper understanding how they work and how they are different. So as you can see, it's nice to use this join because we have to wait for these threads we don't have to use it here, so it just gave us the false result of having like 5 seconds something. But as you could see, this process finish took a little bit longer, right? Let's see this again. Yes, so see, it's still running. So this number, as I said, is not the proper benchmark, right? So it's misleading. The app is still running, and it should write it actually faster. So it's, for example, why you might want to use joins when you have to run stuff like using bare threads, and maybe that's why you shouldn't be doing this because it's confusing, right? Now, so let's keep it with this join, and let's try to run it for 40,000 threads. Right. So if I had this thread per request model, I would try to handle 40,000 concurrent requests. And let's try to do this 20, 25, 30, and kaboom. It went belly up because with the default settings, I have not enough space to accommodate that many threads. So somewhere between 30,000 and 32,000 on this very machine, it goes belly up, right? I could try to reduce the start traces, increase another parameters, and things like this, and maybe I could squeeze and get more threads. But this is the thing. So what we can do now is, instead of having this platform thread, we can try to have a virtual thread. And as you can see, now I'm going for this unstarted. So this is like a thread builder. It gives me thread builder, as you can see, which is a preview feature since Java 19, right? So I'm created an unstarted virtual thread, which I'm going to start in exactly the same fashion, right? And now we're going to try 40,000 virtual threads. Let's see. Oh, they already got created. And now we're waiting, I mean, like the test 10 seconds for the latest thread to finish. Come on. 10, yeah, okay. It finished, right? It did the thing. So let me maybe shorten this duration to 1 second, and let's try, I don't know. Let's be bold. Let's try 100,000 threads. It created these threads, and it's working, right? And come on. Now it's going to complete this and everything, but it created this number of threads. Again, like how does it work? Yeah, it took a little bit longer, but as you can see, I was able to accommodate 100,000 virtual threads, and we could go for bigger numbers and so on. So again, there is no magic, there is no wonderful squeeze of this silicon, right, to get more juice. It's because this thing is waiting during the sleep. The virtual thread goes like this. I'm gonna be waiting now. So I'm telling to the actual OS thread that's carrying me, okay, now I'm gonna spend some time in this restaurant, right? You can go and try to carry other virtual threads. There was a question. Was there a question or not? Yes, please.
I was just wondering how many actual threads were now running those virtual threads.
I'm sorry, could you repeat the question?
How many actual threads were being used by all those virtual threads?
Okay, so the question is, how many actual threads were used by these virtual threads to accommodate all of them? Answer is, I don't know right now, and we should basically see how many they are in the fork join pool, right? And that's the shallow answer. For deeper answer, I don't think we have like, again, this is not like a 3-hour deep dive. Right, so this was one thing I wanted to show you. Yes, so we can just have more of this, and this instead of this blocking operation. So I naively and in a dummy way used thread sleep, right? And this should be like blocking reading from a file or waiting for a network connection, stuff like this. If your system behaves like this, so meaning not that much CPU load, but a lot of waiting or like being blocked because waiting on like external things to happen, then as you can see, virtual threads can easily allow you to have or keep more things happening concurrently, because it doesn't work on this principle, keep the engine running, right? We are not robbing the bank, so the carrier thread doesn't have to keep the engine running. It can go and do other. Stuff. So this is how they work from this high view perspective, right? And let me go for some testing. Let's run this test suite to show you some differences or like new stuff in the API or differences in the behavior of virtual threads. So I'm using JUnit 5 here, right? And we gonna test an unstarted virtual thread. So these methods, stop, suspend, and resume, they were never a good idea, right? So the threading model of Java is based on the principle of monitors. That's why these methods, I mean, they can't work. That's why they deprecated. And whenever you try to call them on a virtual thread, they will always throw you unsupported operation exception. Meaning don't even try, right? And if we try to tell the virtual thread that it's not a daemon, then it will throw illegal argument exception. You can only tell, I mean, virtual thread is always a daemon. It's never going to block your JVM process from exiting, basically. And you can call it with set daemon true as much as you wish. It will just be a no op, right? No operation, no effect. And if you try to do it with false, then it will go belly up, which you can see here. So we can set the daemon, and it's always going to be a daemon. We can try setting different priority, but it's always going to have this normal priority. It won't change. So you can see this thread set priority won't do a thing. It will be still normal priority. Yes, and by default, virtual threads still support thread locals. So as you can see, I have this thread local. Initially, I have nothing in virtual thread. And by the way, I can go, instead of going like thread of virtual start, I can go start virtual thread, another method like a shortcut for this builder, right? And I'm passing a runnable, and I see I have nothing. I set this thread local to 42, and then it's 42, right? And I can opt out from this mechanism. I can say I don't want my virtual threads to support thread locals, and then I can go threads or thread of virtual allow set thread locals false, right? And then even if when I try to set something, right, in a thread local variable, it's going to throw me unsupported operation exception, right? So it's up to us who create these virtual threads whether or not they should support thread locals. And they also support inheritable thread locals, meaning if you have a thread, right, and if you have like a child thread from that thread, initially, I mean, that's the concept of inheritable thread local. It initially should see the same value, although this child thread didn't set anything on its own, right? That's the basically the concept of inheritable thread locals. And you can also disable this, right? So as you can see, it's not going to inherit a thing. Right, so this is like about the kind of like API changes, what happened there. And yes, about the pin stuff. As I told you, using thread sleep is not a very fortunate decision, right? Like we do this sneaky sleep, so it's bad. What's worse than using a thread sleep? Using thread sleep in synchronized block. Okay, that's even worse than this. So let me try to go to this sneaky sleep, and let's try to let's synchronize on this. Try synchronizing on this duration, right? So let's go for synchronized and D. Right, and okay, no, it's not gonna be. It's gonna be the same thing. So we have to invent something clever, like another object. Am I right or am I wrong? Where are we here? It's time to improvise a little bit. So we have this blocking operation, and it's called this job and blocking and everything. So how about creating a little class? Let's call it a job. Right, let's do it like this. Class job, and let's make it static class. So it doesn't have the reference to the parent class, right? And it should have this blocking operation in there. Let's make it a method here, righty. And now let's make this synchronized, right? And so now we're going to create new job, var job equals new job. And here we're gonna say that the blocking operation is gonna be job blocking operation. Oh, sorry, the typo. Like this. Okay, and let's call it then R for runnable. Yes, so we're gonna do something like this, right? And where's we should have this create thread. Right, and okay, yeah, we're creating this like a regular thread, and I'm gonna sleep for 1 second, and let's just create, I don't know, 10 threads. And let's start this. Let's see what will happen. Okay, it worked. We finished running 10 threads. It took us like 1 second, and there was like a slight overhead, right? Just over like 90 milliseconds. Again, it's not like scientific numbers, but this is it. Like, as you can see, we're more like okay, like 20 milliseconds, more or less, for a regular thread. I mean, not regular, for a platform thread or OS thread. Now, what will happen if we switch to virtual thread? And we go for unstarted, not job or but R. Any guesses? How long will it take? Who says 1 second? Who says sub 1 second? Who says like 10 seconds? Still some hands. Let's see. Okay. It finished like even faster, right? But sometimes it might be problematic if we use it in a different fashion, because this sleepy thingy might be different. Let's try something also, something else, and maybe it won't blow. Sometimes it does. Object. Let's call it m new object, and let's try to wait on this object, synchronized on m, right, and here like this and this. And why does it yell at us? On non-final field. Okay, let's make it final so it's not overridden. And yes. So this also works, but this you shouldn't be doing this, basically, because blocking operation in a synchronized block means that this thread will be basically pinned, so it won't be able to yield the control, right? So this is bad, like bad, never do this, right? Just don't. Okay. Let's go to another demo, and there's going to be executors demo, because we have also now new executor service. Again, it's quite similar. What are you running? Let's try to run this. Yes, this executors demo. So it took us 1 second to run, and this perhaps should be the intended way, I would say. Instead of creating these virtual threads manually, maybe we should do it like this. So we create the executor, right? And as you can see, I have this new cached thread pool, righty. So this is like the thing we already know. Like I was here. And then similar, like for every 50,000, I'm going to... no, I'm sorry, I'm in the wrong demo. In this, I should be. Yes, for every 5,000, I'm going to print where I am, and the thing is, it took like 3 seconds, and this thing, when we switch to new virtual thread per task executor, right? But was I running the same thing? Yeah. So as you can see, this is like perhaps the way you should go. And yes, just let me try to go for like low number, like 10 threads perhaps. And let's see, because like, I don't know, maybe other stuff I'm running, I rebooted, so it's like 1 second and something little more. Yeah, so like 105, and let's go for the cached one. And that should be, after a little warm up, yeah, a little bit faster. There's one thing, I'm sorry. There's one thing you should know when it comes to these virtual threads. And I forgot to put it on slide. One of the other thing, which would be like a very bad thing, is you don't pull them. Virtual threads are meant to be single use, okay? So instead of like having single use plastic cups, you should have, or single use plastic bottles, we should go for these reusable ones, but this doesn't apply to virtual threads. They are meant to be lightweight to create and easy to dispose. So don't bother pulling them and doing stuff like this, okay? It's not how things should be done. All right. Yes, structured concurrency. And this is the incubator module. So incubator module works a little bit different than preview feature. Let me show you. So in the POM, you have to go add -- add modules, and add this JDK incubator concurrent, right? And when you run stuff, you should also use this. Should you play with these things, and that is here, right? And let's go for the modifier. Yes, as you can you or can't you? Like, what, do I have it here? Will it run? Let's see if it runs. Let's see in a second. Okay, slides first. Sorry. Yes, this is a 4 to 8 JEP structured concurrency, and I'm not sure if using idiom for this is a good thing, but for example, in JavaScript, we have this await idiom, right? And when you see this, you already realize what's going on in JavaScript or in TypeScript. And there is no await in Java. However, now there's an attempt to have this concurrency structured in a different way using Java APIs. And it's about, or what it should help us achieve is to eliminate the thread leaks and cancellation delays. We'll get to that in a minute. But what it actually means is that we were computing something, right? And we started a number of threads, and we stopped almost every thread except one, and this one thread is still somehow working, right? So we failed actually to stop or interrupt this thread, right? Because interruption is the mechanism in Java, or cancellation delays is about this. We are calculating something, right? And for example, we have to ask this service, that service, and another service, and you should get like a response or responses from every service, and then we should combine the answer, right? And provide it like from these 3 other, I don't know, backend systems, databases, message brokers, whatever. And then one of them fails, or says like, I don't know nothing about this user, and then there is no point in running these 2 other things, right? So ideally, you should cancel that, so these 2 don't spend time, computation power, don't generate CO2 and everything, because there is no point for you 2 to answering, because this guy already said nada, and I need the answer from all 3 of you, right? So ideally, I should cancel these other tasks immediately, and it's not about touching current concurrency stuff. So whatever there is in this concurrency package, like executor services and everything, it should still remain the same. It shouldn't be changed. And it's put very nicely in the JEP. Let me show you that. It says non-goals. Yes. Other structured concurrency constructs can be defined by third-party libraries or in future JDK releases, right? So these other concurrency constructs are, does it ring a bell? Like these async libraries, reactive libraries, things like this, right? So it's like, it's not about forcing anyone to do this thing. It's about like doing this only or solely for Java. Yes. Yes, and it's also not about replacing interruption with cancellation, at least not for now. So for time being, interruption, so thread interrupt and everything stays as it was, but there is a new mechanism which is cancellation. And this whole structured concurrency is built on top of virtual threads. So it's using virtual threads to achieve these goals, right? And yes, so structured concurrency propagates cancellations within the tree, and there are 2 default concurrencies structured task scopes. One is to shut down on failure, and the other is shut down on success. So shut down on failure means that, like in this example I was telling you, if at least one task fails, then we cancel everything. And the shutdown on success is the opposite. Like at least one says it's okay, like I got the result. Think like asking, I don't know, I don't know if it makes sense, but 3 different cache providers, and one of them says, yes, I have this for you. So there is no point in waiting for 2 other caches to respond, so to say, right? Yes, and there is like this mandatory join or join until call. So let me go for this structured concurrency, and let's run this thing. Yes, because what we have in this very demo of ours, how do I, let's go this and shift scan, yes, and big one. Okay, yes. So I have 2 services, name service and score service. The name service gives me the names, like, so I have the user ID and I have the name. I have Joe, Susan, and Krzysztof. Yes, so these are the names, and then I have similar in a fashion, where was the score service, and it just gives me the scores of the users. I don't know, this is like some kind of gamification, I don't know, like karma points or whatever you call it in different systems, like depends on the domain language. And what I need to do is, let's imagine this is an HTTP call, right? So let's say this is the entry, and I'm just going, I'm asked for the scoreboard of all the users, right? So of course this is like a dummy code, but what I want to have is so like this. So we get the names, then we get the scores, and then we combine them. And this combined is really ugly. That's why you shouldn't be looking at this. It's basically only for demo purposes. So it just combines the one response and the other response, and if we have 2 of them together, then we're gonna return this this map, right? And if things are okay and correct, let's as we just run it, as you can see, it takes slightly over 2 seconds, right? And these are the ratings. So Susan and Joe have 100 and Krzysztof has 300. I don't know if it's good or bad. It's just a number, right? A random number, and it doesn't mean anything in this very case. Also, you don't handle exceptions like this, right? It's for demo purposes only. And then finally, we check how much it had taken, right? This whole thing. Righty. And it's just, okay, this was the happy path, right? We test it, we've run it, it works on my machine, let's ship it, right? Unless, I mean, let's emulate that these are network systems, and I should have used, again, like, I don't know, Toxi Proxy or something, but let's play it simple. So let's say there is this name service, and this name service can go, oops, right? Things might not work okay. And if we are fortunate, and if they start not working for the name service at the very beginning, it will take, come on, rerun, it will take no time, basically, to discover, like, oops, things are not going to work, right? And if things are not going to work after, let's say, 1 second, then the whole thing will take, no big surprise, like 1 second, right? Thing is, what happens if score service takes like 1 second to fail, but it also fails? Then we wait for how long? Because we are in this sequential mode, right? So it takes us 2 seconds because we've waited 1 second for the result here. Then we've waited 1 second here, right? So it's 1 second plus another second. It gives us 2 seconds to discover oopsies, right? No scoreboard now, or for today. So we could start thinking, okay, and even if it's like okay, right? If this thing takes a second and this thing takes a second, why should I be doing this sequentially, right? Maybe I shall be doing this like some kind, like in basically do 2 things at the same time. So ask this service and ask that service, and when the results come in, I just combine them then, and I am happy. And then ideally, the maximum time I should be spending this is the maximum time of this task or this task, whatever takes longer, right? Okay, so let's try to go for this approach. And what we're doing, okay, I can use any other executor service. I just decided to go for this new virtual thread to show you that we can use it just as any other executor service. And this is the idiom that we have since Java 7, if I'm not mistaken, right? Maybe I am, I don't know. So we have this executor service, and we submit one thing to do, and that is callable or task, right? And we get a future in a return. So this is one future, and there's a score future, and here we start waiting. We kind of like go for this thread join, right? So here I'm waiting until the names come in, or don't. For example, there might be an error, like a problem, and then I wait for this second thing, right? And eventually I combine the results. So if everything is okay, how much more or less this should take, this future scoreboard? Yes, 1 second, exactly. Like more or less 1 second. Yes, it took like 1 second plus some overhead because things, right? But this is like I said, not a proper benchmark. Question is, how long will it take if getting the names goes oopsies here? In this featured approach. Okay, it should be quick to run. Let's see. So this is like, it should be like, I don't know, network delay, or let's call it whatever. It also takes like more or less 1 second. It makes sense, right? Because this thing waited 1 second and the other thing waited 1 second. Question is, what will happen if we go belly up here? How long will it take? Sorry? Nothing. You said nothing. Okay, let's see. One second. That's the point. Who's surprised that it took 1 second? People are surprised. Yes, see, and this is the problem, like the mental issue, so to say, with this fork approach. Let's go again through this. We have waited here for almost no time, right? But then this thing was waiting for or working for 1 second, because we submitted it here and we waited for 1 second. Because when we fail here, we don't tell this future, hey, there is no point in waiting. That's the point. That's why it still works. It's still busy for 1 second. That's exactly the point. We didn't signal like, don't bother. Okay, does it make sense? Right, that's why it takes 1 second. That is the reason. And let me comment this out. So what should we do this? Or when we look at this code, what does it tell us? Like this future and this future, they have no dependencies. The only dependencies that exist when we look at this piece of code exist in our brain for like 5 seconds, maybe. Because this is concurrency, this is hard stuff, right? Let's be honest, especially if it's like Wednesday afternoon and you feel like if it was already Friday. I mean, this is how it is. Like, this is not like to be a like sarcastic joke, and you know, in this like Eastern European approach and something like this. It's basically the thing. So what we could do, it's basically monitor for this code if it fails, or like this future, then for this if it fails, right? And then we should get these errors that get these exceptions that get thrown, right? Or get the failures, and then we should cancel every other future, like make sure you don't wait. Who wants to write this code? Yeah, there are so 2 people. If there's more than 2 people, I'm sorry, I'm blinded by the lights. Right? But you see that there's this, I mean, we have to put extra effort to write this code, right? Because this future and this future, they know nothing about each other, right? So now, like, I know maybe this reference is not very fortunate, but I love records in Java. Of course, I think we should use them when they should be applied and when they play very nice the role of being immutable carriers for data, right? And because they bring structure, they bring like Java language specification and everything to how we structure our data. So libraries, instead of relying on this clumsy getter and setter, kind of like gentleman agreement, can go for like a firm like accessors, constructors. You will get this and that and everything. So it's like then it's like proper and it's guaranteed. Then the data is structured in a Java way. And so is the approach with structured concurrency, that we structure concurrency in a certain way so that it's easier for us to reason about it, to understand it, and also for the JVM to do the job for us. So let's go for the structured scoreboard, right, which looks like this. Does it look kind of like similar to the previous example? Let's see if we can fit both in the screen. Shift 12, move, yes. Yeah, they look kind of like similar. All right, we have try with resources. It's just now, instead of executor service, we have this scope, right? This scope. And I asked it to be shut down on failure, one of the default two. You can implement others if you please. Like, I don't know, like I need 3 out of 4 or whatever, like something like this. Anyway, and then we have this scope, and instead of submitting, we tell to fork, like create like a subtask or child future for us, something like this. And then I provided with exactly the same thing. And then after I create or submit every task I need, I have to join. So I'm waiting for everything to complete. And if there were any errors, if there were any problems, I want to throw an exception, right? And then, as you can see, then again, so this is like extra, like it doesn't exist here. But then the same is exactly the same, except like instead of get, I'm calling result now to get the results. So if we call the thing and we have no oopsies here and no oopsies here, how long is it going to take? 1 second. Again, like, yes, we're not going to squeeze any extra juice out of the silicon because there is none, right? Oops, it doesn't work. Yes, see, it doesn't work because I don't have this module, right? So I have to go here and go for, let me open the POM. This is the name of the module. Let me go here. And when we run the thing, just like with this enable preview, we have to go for what was that? Add JVM options, -- add module. Suck, and let's see if it works now. Add modules, I guess. Sorry, typo. Add modules. Yes, and it warns us, and it took like more or less 1 second. The thing is, what will happen if oopsies happen, for example, to score service, and they happen early? Let's go for this import, right? So this thing should be running, and this thing fails quickly. How long the whole thing will run? I hear zeros. Let's see. Let's run this and see. Yes, close to 0. So as you can see, actually this structured concurrency is nothing fancy. It's actually how we think about concurrency, right? So we thought here that it's gonna take 0. It took 1, and we are surprised, and then we realized, yes, because the failure in one place doesn't make it propagate to the other parts, right? And this is actually how it works here. Right, so this thing failed here. It failed quickly, so then it notified the parent thread and every like sibling threads and everything, and we could we could go deeper, right? So each of these could have their own forks and so on and so on, right? Then the whole if we have this shutdown on failure in one place, this is the scope, then a failure in one place would mean that everyone would stop bothering, basically. That's why, and then we have like this throw if failed and everything. And there are two things that come to this structured concurrency, and pretty much like we had with this foreign memory things, right? So let's try to misuse this scoreboard, and as you can see, now I'm going to call scope fork in another thread. Right, so I'm not going to call it, let's say, in the family or in this, how is it called, a flock, if I'm not mistaken, but let's call it from another thread, and let's see what happens. And it throws us an exception, very nice. It says, current thread not owner or thread in the tree, sorry. Meaning it's not the parent doing this, or it's not one of the forks that tries to make like a deeper forks, right? So I can't, this is what it means, like, the threads cannot leak. They cannot leak because it's like someone suddenly can't use it in another thing. Yes, and then what will happen if I forget to join? Then it should also fail, yes. Oh no, it doesn't. Why it doesn't? Am I doing something wrong, or let's see. Oh, I guess I know why. Sorry, of course. Am I right? Yes, because this oops is here, right? And now, yes. So I have proper tasks. They are not failing, and I have no scope join. And I don't know why. I mean, the demo goats aren't with me. I was expecting this to fail. Like if I don't join, it should also it should go belly up. Or maybe I guess I'm holding it wrong. Sorry. Maybe it's. Oh, come on. It's something, the IDE gets stuck. Yes, it's like, now it's always typing E. Oh, sorry, maybe this thing. Why, like whatever I do, my machine got crazy, or what is the thing? Now, here it's typing properly. And here. Okay. Interesting. Let's try behave. And without join. I messed up something. I'm sorry. Like I messed up something. Let's see if what the JEP says about the lack of join. Join, yes, we still have to join. That's the old code, and the right, propagate the error, cancellation. Joining. Yes, calling either join or join util until within a scope is mandatory. If a scope block exits before joining, then the scope will wait for all forks to terminate and then throw an exception. So this should happen, and like really was happening yesterday. It doesn't happen today. I really don't know. I am embarrassed, but this is what it is. Unless you see like a mistake that I did, but I can't see any right now. Let's try to roll back. Maybe I messed something else, and see one more time. Let's go from this to this, and let's see. That should be the thread thing. Yes, because it's this thread, and now instead of this, let's go for this without join. It works. I mean, it shouldn't. I don't know why. I'm sorry. Sorry? Yes. Yes, of course. You see, this is like a bad code. Right. Task has not completed. Exactly. Thank you. Please make sure you get some jellies. Of course. How silly of me. Yeah, like let's give this guy bravo. Like he did a very nice thing. Yes. E print stack trace. Let's print it. Yes, task. It said even said task has not completed. But let's. Yes, that's the exception I was waiting for. See, so it says task has not completed, and it says owner did not invoke join or join until. So these are mandatory, and as you can see, so this structured concurrency does several things. First, it has this proper cancellation propagation, right? So if this thing fails early, then everybody else is notified and they are not working, right? They stop working immediately. Then, as you could see here, it makes sure that we don't leak it to other threads, right? So there's no thread leak and everything like this. And then that we also holding it correctly by calling this scope join. If we don't do this, if we don't scope join or scope join until, like sometime, then it's going to yell at us basically that the task has not completed and hey, you didn't invoke join or join until. So yes, this is it. Okay, let me go to the slides. We still have like a few minutes left. Yes. So other things. This we have done. Like some to throw some vari at you. There were some changes to Java 18, and the most the garbage collectors in Java 18, and the most significant one is that string deprecation now happens for these other garbage collectors as well, right? Not just G1. For Java 19, there weren't many changes to garbage collectors, so I'm like still it's there like for you to look for it, especially if you're the person who takes care of the production, how stuff is running there. There is the automatic generation of the CDS archive, so it's getting better and easier to use and everything. If you're not familiar with class data sharing archives, and you do care about startup times and you can't afford to go for Graal, then you should look at CDS archives. I think I did talk about this like last time at Devox when they introduced this mechanism, right, to Java. Now it's getting better and better. Yeah, we have Unicode 14 now in Java 19 because we apparently need all these new emojis. Yeah. And they added also other stuff, not just emojis, right? But several emojis, like as if there wasn't enough. Anyway, there are two new properties. Like when you call system get properties, it's encoding of the standard output and standard error. And there is additional date time formats. So let me run this quickly for you. Oh, and there's one more thing, if I'm not mistaken. Yes, new methods to create pre-allocated hash maps and hash sets. So we should have the Varia thingy. Yes, that should be the last demo today. Let's run this. Come on. Yes, very nice. So we have some locales, right? And now we can create locale using the off method. See, it's a new method since Java 19. We just go for locale.off, right? And so I'm creating locales for all these beautiful languages, and then I'm going for datetime formatter builder. And previously I could go for this short, medium, long, or maybe there was like a fourth one, I don't know, like three were for sure. And now I can go for this append, like a localized pattern. And as you can see, it can, like, despite I use 3 like for a month, in certain languages, for example, it appends the dot which makes that 4 languages. And even if the order is, like I said, year and month, it's basically, it's localized. That's the whole point of this, right? And you see this new method that I'm like pre-allocating or saying like, hey, I need a hash map, and just give me hash map ready to accommodate 2 elements. So I could, like, if I know beforehand that I'm gonna say, for example, have like 5,000 elements, I could say 5,000 here as the size. So instead of like growing this and like a set, right? So it then has to grow and then garbage collect the whole thing and everything. I can tell, like, this is like a hint. I know how much I'm gonna need, so please make sure you have that much space for me, right? This is also like new since Java 19, and these 2 new properties, as you can see, standard output encoding and standard error encoding. These things got printed out. Right. So there's some deprecated stuff. Thread stop got deprecated terminally. Very nice. I mean, what took you so long? But anyway, the constructors of locale got deprecated. So that's why we should be using locale.off, not new locale. Or whatever that is pronounced, and some stuff got removed. So in if I'm not mistaken, in Java 15 there were new implementations for socket, right, of plain socket in the datagram, and the old ones were still around. Should you want to like fall back to them because you relied on some undocumented features of theirs. Now they are whoopsies. Now they're gone. Very nice. And now, I mean, I've been talking here for almost 3 hours, I mean, with the break and everything. And now it's time for you to do something for yourself. And it is to provide the feedback, not just me, but every other speaker and the conference organizers and all event organizers and so on. And I'm saying this not only to the people in this very room, but also to you if you're watching this on YouTube, even like a few months later, right? So for people who are, like, I can accept any form, like you can even give me a paper. The preferred one, as far as I can tell, is to use the Devox app and go for this vote button here. So you let us know what should happen next time, for example, if you like this formula of the talk or not quite, what should be improved, not quite, what should be improved, and so on and so on. If you can't use the application because whatever reason that is, or you're watching this a few months later on YouTube, no worries. Then I'm asking you to go and fill this anonymous survey. I mean, it's anonymous from my point of view. I don't know who you are unless you introduce yourself, and you could tell me what you like or what you didn't like and so on. So please take some time to scan this. And like I said, even if you're doing this or watching this on YouTube later, please also like provide your feedback, right? And of course, hit like and smash that subscribe button. That's the mandatory phrase, I guess, for YouTube. Yes, so this is the poll. Thank you very much for attending this talk. So this is me. These are the slides. This is the code, and this is the last slide for this is the link that will get you everything. The whole presentation and the other links are embedded inside. I'll be here at Devox till Friday, and if you have some questions, if you'd like to discuss something with me, not only Java, but also like, for example, test containers and the other stuff, just as my speaker's uniform says, I like talking to you, so please come and talk to me as well. Thank you very much, and please go and use new Java version. Thank you.